Hey everyone, in this video I want to talk about how we can graph inverse functions. So let's go over a review of inverse functions and then we'll get into graphing them. Quickly, remember that a function is just a one-to-one input to output transformation. So we give our function an input and it'll give us a single output value. Well, an inverse function is just the opposite of this. So it is basically asking us what function can we apply so that this output value gives our input from earlier. But why do we need this, you may ask? Well, the purpose of learning inverse functions is to be able to unpackage functions, if you will. So, for example, if we want to find the value of x here in this function 3 to the power of x, how would we tackle this? Well, you may have heard of logarithms, which can unpackage exponents. That is, it can bring the exponent to a coefficient in front of this 3. Then we are able to solve for it. We're able to do this because these two are inverse functions. So if we plot an exponential versus a logarithm, you can see that they mirror each other about x equals y, which we discussed in the last video is an easy way to visually see that a function has an inverse. So what steps should we perform when graphing an inverse function? Well, firstly, we want to create a table of input to output values just like we did when graphing regular functions. Through this, we will get a list of ordered pairs that we can plot on a graph. Once we have graphed our initial function, we are ready to graph the inverse function. And here's the cool part. In step 2, let's just copy our table here, but we are going to switch the x and y information. So in our inverse table, all of our x values will be the y values from our previous table. We know that we are allowed to do this as our function and our inverse function are reflections of each other about the x equals y line. And that's really it. If you can just remember these two steps, you can graph inverse functions. Just as a quick note, if you are given a graph and we are told to draw the inverse function, all you need to do is draw a line at x equals y and mirror the function given to you, like so. Whereas if you are given a table of values like so, all you need to do is swap the inputs and outputs like so, and then this will give us a table that we can plot easily. In my examples here, I will also show you how to find the inverse function like we talked about in a previous video, and prove that we can just mirror the information in the graphs here. Alright, so question 1. Find and graph the inverse function of 2x plus 1. So let's just begin by finding the inverse of this function. So remember, step 1, in finding any inverse function is to solve for x. So let's move the 1 over to the left side. Then we can just divide by 2 and isolate for x. Then also remember that for our inverse functions at this point we switch x and y. The reason for doing this is because the former x term here in our original function is now going to be an output of our inverse function, where before it was an input to our original function. Likewise, our former y is now the input to our inverse function, whereas it was the output to our original function. So it is just for consistency. So let's just pick a few random points and fill in this table here for our original and inverse functions. As you can see here, our inverse function table is indeed the opposite of our original function table. This is a really nice way of solving these types of problems, as you can validate that no errors have been made. By that, I mean if your x and y values do not match when switched in the inverse function table, then you know the function is not invertible or that an error was made. So then we just need to graph these two functions, and this is our final answer. We've now finished this question. Let's do another example. Let's say that we have x squared. The inverse of this function is the square root of x. Then all we have to do is change our x's to our y's, and we get that y equals the square root of x for our inverse function. I'd recommend you take a moment here and try to solve the rest of the problem on your own, and then we can compare our answers, as this is a good way to make sure that you actually understand the material. Now back to the question. Let's just repeat what we did last time. Let's just pick a few random inputs and fill in the outputs into a table here for our original and our inverse functions. Again, for this inverse function, you can see our inverse function table is indeed the opposite of our original function table. Like I said earlier, I recommend doing it this way on your test too, if you have time, as it allows you to ensure that no errors were made. If your x and your y values do not match when switched in the inverse function table, then you know the function is not invertible or an error is made, like I said earlier. So then we just have to graph these two functions, and this is our final answer. Next, let's perform strictly a graph question. So let's say that we are given this function here, and we are told to draw the inverse of this function. Well, this is going to be easy to us now. We just draw a line along the x equals y line. Then we simply mirror the points across the line like so. If you find this difficult, all you need to do is identify some points on our original function and swap the x and the y values, and then plot them again. So you will get the same answer either way. Lastly, we are told to find the inverse of the following table's information without graphing the function. Well, we can also now do this easily. Let's just begin another table here, and then we can take our output information from our original function and use that as our input information to our inverse function. Then we can do the same for our output information for our new table. And that is all we need to do for this question. We are now completed. Thank you for checking out this video, and I hope it helped your understanding of how we can rather easily graph inverse functions. If you enjoyed, please like, subscribe, and consider checking out our Patreon page to support the channel. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.